Yo, what's up, guys? Can you hear me? Hello. Yo, can you guys hear me? Yeah, we Speedy Memes is having a technical difficulty, so we will delay the start. So yeah, we are going to Why are we starting? Okay. We will begin shortly. I need to find my timer. Okay. Find all real solutions of the following equation. Okay, so we got this 125x to the cubed. So that's 125 is 5 cubed, right? So this is basically like 5 to the power of x cubed minus 5x squared plus 11x minus 3 is is equal to 5 5 to the power of x squared plus 3, right? So because f of x equals 5 to x is increasing strictly, then you get x cubed minus 5x squared plus 11x minus 3 equals x squared plus 3, right? So, well, this is a cube x, so x cubed minus 6x plus 11x minus 6 equals 0. Oh, this is the classic. This is the classic. So we know that we can factorize this as x minus 1, x minus 2, x minus 3 equals 0. So x equals 1, 2, or 3. Okay, and then we need to check our answer, right? We need to check our answer. So 5 5 to the power of, what is this? Oh, shout out to my boy Vinayak Yoshi for lending me this calculator, by the way. My one wasn't working, so shout out to him. Um, to the power of x cubed minus 5x squared plus 11x minus 3. Okay, 4 fourth root of 5 to the power of 4x squared plus 12. Oh, wait, I'm in the wrong place. I'm in the wrong place. Okay. Bro, I don't see shit. Okay, G solve intersection. Okay, x equals 1. W. X equals 2. Okay. X equals 3. Okay. We got it. Okay. Find all complex solutions of the following equation. Okay. Z lit Z equals x plus iy. Okay. So x plus iy equals to um 2 minus 2 plus I over ix minus y. And then we rationalize, sorry, whatever you call it, we normalize the denominator, and then you get 2 minus 2 plus I times minus ix minus y over, okay, now it's ix minus y times minus ix minus y Brother, this is so cooked. Okay, equals 2 minus. Okay, bro, I'm gonna be real. I forgot how to do this complex numbers. Uh, minus 2ix minus 2y plus x. Okay, minus iy. Okay, I believe this is correct. And then all over, um, brother. Um, so we know the denominator is rationalized, so they won't. Oh, it's just x squared plus. It's just over x squared plus y squared. No, because yeah, you rationalize it. Okay, so um, so yeah, so x plus iy times x squared plus y squared is equal to 2x squared plus 2y squared minus. Okay, and now so it's minus that, so it's plus 2ix plus 2y minus x plus iy. Okay, I think this is correct. I think this is correct. Okay, so now if we take this over to the other side, what do we get? What do we get? What do we get? Um, so we get x cubed. Okay, this is not looking good. X cubed plus xy squared minus 2x squared minus 2y squared minus x plus 2y. What the? Plus x minus 2y. Um, plus I times x squared y plus y cubed. Um, minus 2x minus y equals 0. And then we need to solve this simultaneously in x and y. We might be cooked. Wait. Wait, no, 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 no. Wait. Like, it's Z, right? Wait. Yeah. Wait, like, bro, you do not. Sometimes you do not need to bash TS, right? So, okay, so, like, so you get like, if we just expand it normally, right, what do we get? We get like Z iz squared equals 2iz minus 2 plus I. And then, okay, so iz squared minus 2iz plus 2 plus I equals 0. Okay, and then we just do quadratic. Bro, TS is not tough, man. Okay. Z equals 2I plus or minus the square root of b squared minus 4ac. So b squared is obviously, so negative 2y, and then you square that. So you should get negative 4 minus 4i 2 plus I. Alright? Over 2i, right? Um, is this good enough? Well, so what is this? Is like 1 plus or minus 1 over 2i times the square root of negative 4 minus 8i plus 8. 1 plus or minus, so the 2 can, so that's plus 4 minus 8i, right? So that's square root of 2i minus 1, I guess. 1, 2 minus 2 plus I over I times the square root of, sorry, I times 1 plus the square root of 2i minus 1. Nah, I'm cooked. where did we mess up? Where did we mess up? Wait, yo, we're getting cooked today. We're getting cooked today. Um, okay, iz squared equals 2iz minus 2 plus I. I take it over. Okay, z equals negative b plus or minus the square root of b squared. So negative 2i squared is minus 4ac, so 4ac over 2a. Okay, well let's just go like I don't know, like 2i plus square root of negative 4 minus 4i, what? Minus 4i times 2 plus I over 2i. What? Yo, Chad, where did I mess up? Why is it oh, wait, so if I go 2 minus 2 plus I uh over iz, then it's wait guys, I think I might have I might be cooked. I might be cooked. And then what's the other one? Is gotta wait. Oh wait, this one doesn't have. Okay. Wait, so it's just I then. It's just I. Wait, what's the square root of 2i minus 1? Okay, no. There must be something wrong. There must be something wrong. Guys, this is not looking good. This is not looking good. Okay, so we know. So the quadratic is correct. So iz squared minus 2iz plus 2 plus I equals 0. Therefore, z is equal to 2i plus or minus the square root of negative 2i squared b squared minus 4i 2 plus I, right? Over 2i. Alright, okay. So, 2i plus or minus the square root of. So what is 2i squared? Like what is like minus 2i squared? That's minus 4. Yeah, that's what I said. That's what I said. Minus 4 minus 8i. Okay, and then what's minus 4i? Minus 4i times I. That's 4. Wait. Yeah. Oh. Wait, real. Okay. So, yep. B. So, so that's 2i plus or minus. Wait, that still makes no sense though. Plus or minus the square root of negative 8i over 2i. Oh, real. And then obviously this is 1. So then it's plus or minus the square root of 2i. Why 2i? Because square root of the square root of 2i is just 1 plus I. Yeah. So this is 1 plus or minus 1 plus I, which is equal to plus or minus I. Okay, good question. Okay, how many different complex solutions? How many different complex solutions does this equation have? Okay, so this one I'll do polar. Let z equals r cis theta. Okay, right. So then by the MOV r to 2025 cis 2025 theta is equal to r cis negative theta. So if r is not equal to 0, then r to the 2025. Well, no, this also applies if r is equal to 0, I guess. So r 2025 is equal to r. Therefore, r is equal to 0 or 1. Right? Because r is real, right? So case 1, if r equals 0, then obviously z equals 0, right? So let's consider the case. So if r is not equal to 0, then r equals 1. And then so 2025 theta is equal to negative theta plus n pi, right? Or is it 2n pi? Um, um, Wait, I think this is in the formula sheet, guys. I think let me look up the formula sheet. Okay, I think it is. Wait, yeah, I think it is 2n pi. Okay, so we get like 10 13 theta is equal to n pi, right? And then so theta is equal to n pi over 10 13 for some n which is an integer, right? So okay, this should be good. Okay, so but obviously like once theta loops around, right, like you're cooked, right? So if but we only consider 0 less than or equal to theta less than or equal to 2 pi. So 0 less than or equal to n less than 2026. Therefore, there are 2026 cases. I do believe this to be the case, right? Yeah. So therefore, so there are 2027 cases in total. Okay, let z equals r cis theta be a complex number. Oh, if angle ABC, wait, what? Okay, so obviously like, okay, so r greater than 1, so, and 0, so r is, z is like somewhere here, right? So, let's pick like z here, and let's draw the unit circle. Um, wait, why is this so weird? Unit circle. So, okay, so say this is 1, this is 1, okay, so that's z, right? So, okay, so, if, so, so b is z conjugate, right? Okay, so b is z conjugate, so, okay, so z is in the first quadrant and outside the unit circle. Right, and then, okay, so B is, so 1 over Z, what's 1 over Z? So 1 over Z is basically like, it would be like inside the quadrant, but like reflected, right? So it's basically like an inversion, but like reflected, like inversion and then like rotated like 180 degrees, right? So it would be like, it'd be like here. Well, I mean, okay, like if I was doing this properly, I would be like calculating the lengths and everything. Like I really can't be bothered. So, okay, so C is like here. C equals 1 over Z. And then D is equal to IZ. So D is just a 190 degrees rotation, right? So D is equal to IZ, right? Okay, so what we have A, B, C is 60 degrees, right? So, okay, so this is 60 degrees, right? BC is 1.5. Then they want you to find the area of the quadrilateral ABCD. Okay. So this is a tool for our friend um coordinate bash. I think wait, can we quad bash this? Let me think. So no, maybe we can trick bash this. Maybe we can trick bash this. So obviously B is the reflection. Bro, this is like the opposite. This is like the opposite of complex bashing a geometry problem, right? Like we're trying to use geometry to solve a complex numbers problem, bro. That's kind of crazy. Um, so B is the reflection of A in the real axis. Okay, and then C. Okay, I can't really represent C. Okay, but what do we know? We know that like this length, like if this if let A equals R, then C equals 1 minus R, right? And D we can think about D later, right? Okay. So basically like if we find this length like R and then this angle theta, then we're done, right? So this length is 1 over R, right? So we know this is 1 over R. And then this is a straight line. So maybe we can cook some like maybe we can cook like some like synthetic geometry. I don't know. Like cause what are these? Bro, is this like a cyclic quad, bro? Is this like a cyclic quad? No shot. But why would they give you 60 degrees? Wait, so we need to relate somehow. We basically need to calculate like theta and r in terms of angle ABC and length BC, right? So we can use trig for this. We can use trig for this. Um, let let A equal sorry, let arg A equals theta, then arg B equals negative theta, arg C equals 1 theta plus pi, right? So like we basically know this length is equal to this length, right? So what are we trying to cook? Then this angle is 60 degrees. How does that help us? Bro. Wait. Wait, hang on. Wait, B is Wait, we might be cooked. Wait, hang on. Arg C isn't arg C negative theta? Right, okay. So actually C is like on this line with B as well. Wait. Guys. Chat. Like if this is the like if this is a circle, right? Right, we got A. Let's say A is like okay, I'm gonna draw 3, 4, 5 this time, so it's easier to brother. Okay, A, B, so B is down here, right? B is Z conjugate. So okay, so then C, because arg C is negative theta, not theta plus pi. So arg C is actually like on this line. Okay, that kind of makes things like, and let's call this O, right? So okay, so let's not think about like, wait, bro, this is okay, this is like, this is kind of trivial now, no? Like, wait, this is kind of trivial. This is kind of trivial. Okay, so wait, 1 over Z. Yeah. Okay, okay. So basically, um, C is equal to 1 over R, and B is equal to R, right? And then arg B is equal to arg C. So BC is equal to R minus 1 over R, which is 1.5. Therefore, R is, oh, you can calculate this, like, it's not that deep. Like, 2R squared minus 3R minus 2 equals 0. R equals, like, brother. 2 minus 3 minus 2. Oh, yeah, okay, so R equals 2. Wait, that's so nice. Okay, R equals 2 because R bigger than 1, right? Or at least 1. Okay, so we're given this, and then, oh, then this is just a right angle triangle, bro. Like, this is a right angle triangle. Like, AB is perpendicular to the real line. So, um, B angle arg B is equal to negative um, pi on 6 by right angled triangle. Okay. We're cooking now. We're cooking now. Okay, so wait. I think this is like this might be enough to finish, right? So okay, so like if you look at this, like obviously the diagram is like way not drawn to scale, right? But okay, so now we rotate this by like 90 degrees. Well, like okay, like if we quad bash now, right? If we quad bash now, um, how are we? Are we cooked? If we quad bash now, I think like, well, okay, so A equals 2 cis pi on 6, which is 2 sine pi on 6. 2 cos pi on 6. That's what? That's root 3 plus I. Okay, so B is equal to root 3 minus I. C is equal to whatever like a half of that is, I guess. Root 3 on 2 minus I on 2. And then D is equal to minus 1 plus root 3. Okay. Now we're good, right? Because we can use like whatever formula. Like, okay, so like AB equals 2, right? By sine rule, area triangle ABC is 1/2 times 1.5 times 2 times sine 60 degrees, which is sine 60 is pi on 3, right? Squared. Um, 27 on 16. Square root of 27 on 16. So like that, what? That's like what? Like 3 root 3 on 4? Okay, but we still need to calculate this. Wait. If that's 30, that's 30, and that's 90. So this whole thing is 150. So we can't. It's not a straight line. It's not straight, we actually might have to think about this one. Um, bruh. Okay, area triangle ADC is equal to. Wait, let me just double check. 3 root 3 on 4. Yeah, okay, that's the same. Okay, so um, yeah, AD squared is equal to 2 squared plus 2 squared. Um, so AD is equal to 2 root 2. Do we know this angle DAC? I mean, you could just like, I mean, you could just fully bash this like CD squared is equal to 1 plus root 3 on 2 squared plus a half plus root 3 squared. Bro, bro, we might be cooked. We might be cooked. We might be cooked. CD squared. Um, hmm. I can just finish my herons. Like, I think but like, I don't, I don't think I'll get the exact form, right? So that's why like, wait, do we care about exact form for skull calculus? I forgot if they care about exact form. Like, if find the area of the quadrilateral ABCD. Okay, let's draw like a bit of diagram. Actually, whatever. Should be fine. Should be fine. So that's like that's O. So ABO is actually is actually equilateral, right? So these are all two, and then like we have like a right angle up here, which is D. Wait, wait. So like area of ABCD, right? Is like area of ABCD is equal to area of ABO plus area of AOD. This is 2 and 2, right? So minus area of COD, right? So A ABO is like a right angle, is like is equilateral, so we can just calculate because that we know that's root 3, that's 1. So this is just root 3 plus 2 minus, so what's COD? So COD, we know this is 30 degrees, right? So what is this length? That length should be 1. Am I tripping? Am I tripping? Like, is that not just a half? So that's root 3 plus 7 on 4, right? I mean, mate, like, I don't know. Like, I don't even know how to check this. Like, well, I go back and bro, it's over. Okay, wait. It should be fine. It should be fine. I'll come back and check it later. Okay, okay. Okay, okay, okay. Parametric d squared y over dx squared is equal to what? Bro, is this you literally just plug in parametric second derivative formula? So okay, so yeah, like y is equal to at cubed plus bt squared plus ct plus d. X is equal to 2t plus t squared. Um, dy squared over dx squared is equal to d by dt of dy by dx times d times dt by dx. What the? Okay, wait. Okay, and then this is just d by dt of dy by dt times dt by dx. Okay, so this is just d by dt of um 3t squared plus 2 over 2 plus 2t times 1 over 2 plus 2t. Okay, this don't look so bad. Okay, so we just do like quotient rule, right? And then what do we get? We get 2 plus 2t squared. So what's quotient rule? G times f prime. Okay, 2 plus 2t 6at plus 2b minus 3at squared plus 2bt plus c. And that's times 2, right? Yeah, it should be. Um, that's cute. I hope I did this correctly, otherwise I'm just completely cooked. Hmm. And then now we just, presumably we just expand this, right? Because we get like um hmm like obviously if you look at this, like two of those 2 plus 2 t's have to come out, right? So the top must be divisible by another two factors of 2 plus 2. Like at least this must be divisible by 2 plus 2t, right? So I don't know, can I just say that? Like, well, let's expand. Let's expand. Let's hold that thought. We expand and then we'll see what happens. Okay. So we get what we get. We get 12at squared plus 4bt plus 12at plus 4bt. Wait, no, I already did that one. What? Plus 4b, right? Minus 6at squared minus 4bt minus 2c. Okay, so okay, we get cancel. We get cancellation. Okay, so that cancels. That cancels. Good. Over what is this? 2 plus 2t cubed, right? Okay, and then so that kind of cancels as well. So we get 6at squared plus 12at plus 4b minus 2c over 2 plus 2t cubed, right? So and that actually let's write that out. So that's 4 1 plus t. Um, let me I can do this. 2b minus c. 4 1 plus t times 1 plus t squared. So okay, so and then we get this 3, right? So obviously, so this has to equal 3 times 3 over 4 1 plus t given, right? So that means that so if we cancel these, so we get that like 3at squared plus 6at plus 2b minus c is equal to 3t squared plus 6t plus 3. Wait. Oh! Okay. This is winnable. This is winnable. Okay, so yeah, so therefore by comparing coefficients, a equals 1 and then 2b minus c equals 3. Okay. And then so now we plug this in, right? We plug this in. So p of 1 is equal to a plus b plus c plus d equals 2.5. Therefore, b plus c plus d equals 1.5. P prime of 1 is equal to, well, it's 3a plus 2b plus c, which is equal to 6. So 2b plus c equals 3. Okay, and then now we put this into the equation solver, right? I mean, this one. Okay, so we got 0, so we got 2, negative 1, 0, 3, 1, 1, 1, 1.5, 2, 1, 0, 3. Wait, is that real? So solving these three equations simultaneously, b equals 1.5, c equals 0, d equals 0. Um, Therefore, p of 2 is equal to, yeah, 8a plus 4b plus 2c plus d should be equal to 8 plus 6, 14. Okay, I hope that was correct. Okay, so consider wait, bro, wait, they're giving functional equations in in, in scholarship calc. What, brother? What is this? Wait, yo, if, if of 1 minus x is equal to f of 1 plus x, okay, so let p of x be the assertion that f of 1 minus x is equal to f of 1 plus x. Alright, so p of 0 implies that f of 1 equals, okay, that wasn't very useful. That wasn't very useful. Okay, okay, what are we doing? What are we doing? Um, okay. But okay, so if is odd, so f of negative 1 equals f of 1 equals 2025, right? Okay, then, okay, so p of 2 implies that f of negative 1 equals f of 3, which is also equal to 2025. Alright. Oh my, are we proof by induction? Okay, okay. Claim. Wait, but what if of 2? If of 2 is if of 0, right? Wait, so you go like negative 1 to 3 to negative 3 to 5 to negative 5. Okay, so claim f of n is equal to for all n natural f of 2n f of 1 plus 2n for all n is an integer, n greater than or equal to 0, I claim f of 1 plus 2n equals 2025, f of 1 minus 2n equals 2025, right? So okay, so right, like proof by induction, base case n equals 0, f of 1 equals 2025, given inductive step n f of 1, so we have to go from the big to the small. So f of 1 plus 2n is equal to f of negative 1 minus 2n, odd, which is equal to f of 1 minus 2n minus 1 equals 2025. Therefore, f of 1 minus 2n equals f of 1 plus 2n equals 2025, given. And then, so this concludes. Okay, so now we have to get f of 2, right? So f of 2 is equal to f of 2 is equal to f of negative 2 by odd, which is equal to f of 5. Wait. No, that can't be right. Wait. Wait, wait, yeah, how you... Is it not unsolvable? Wait, like how? Wait, a function f is said to be odd if f of minus x equals minus f... Oh, wait, okay, so equals minus f of 1. Okay. Wait, yo. Wait. Okay. No. Wait. This is cooked. This is cooked. This is cooked. Um, why is this cooked, right? Because so if it's odd, right? So if of -1 is actually so this is actually negative 2025. This is negative 2025, right? So okay. So p of so then f of -3 is equal to negative f of 3, which is equal to 2025. P of 4 implies f of 5 equals f of 3. Sorry, what? F of negative 3 equals 2025. Okay, so this is skull calc, so I'm going to be non-rigorous, right? So I'm just going to say continuing in this manner. Um, f of like 7 equals f of 11 equals dot dot dot. So what is it actually like? Um, so you end up at 2015, 2019, 2023. Okay, f of 2023 equals minus 2025, and then f of 9 equals f of 13 equals dot 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 equals f of 2025 equals 2025. Yippee! Okay, so basically what we get is that f of 1 plus f of 3 plus f of 5 plus dot 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 plus f of 2025 is equal to brackets f of 1 plus f of 3 plus f of 5 plus f of 7 plus dot 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 plus f of 2025, which is equal to 2025. Right? Yippee. So we done the odd one. We done the odd one. So let I assume a similar trick will work for the evens, right? So let f of 2 equals uh a. Okay, then f of -2 equals minus a, but by p of 3 implies that f of 4 equals f of -2 equals minus a as well. Okay, I see how this works. Okay, so then f of -4 equals negative a. P of 5 implies f of 6. Wait, that's a. F of -4 equals a. Continuing. So I'm pretty sure induction is not actually in the level 3 curriculum. So they cannot they cannot expect you to do a proof by induction. So we will just say continuing in this way. Um, f of 8, f of 10, etc. alternate between a and negative a, since 2024 is a multiple of 4. F of 2024 equals f of 4 equals minus a. So okay, so then we're done, right? So basically we say f of 2 plus f of 4 plus dot 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 plus f of 2022 plus f of 2024 is equal to a minus a plus a minus a plus dot 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 plus a minus a equals 0. Therefore, sum from I equals 1 to 2025 of f of I is equal to 2025. Yeah, good question, good question. Okay, okay. Consider the brother. Consider the cubic function. Okay. Lines A, B, AC, and BC intersect the cubic uh, B, AC and BC intersect again at D, E, and F. Okay. Find the y-intercept of the cubic. Consider the function g of x. Okay, so I see what they're doing, right? So g of x, g of x equals f of x minus x squared, right? G of x equals f of x minus x squared. Um, and we know that g of 2, um, g of 2, let g of 2 equals f of 2 minus 4, which is 0. G of 3 is f of 3 minus 9, which is 0. G of 4 is f of 4 minus 16, which is 0. Wait, so wait, this is actually a cubic, so this you're done, right? So g of x, since g has roots at 2, 3, and 4, then g of then x minus 2, x minus 3, x minus 4 divide g, but g is cubic, so these are the only non-constant divisors, factors. Therefore, g of x is equal to k x minus 2, x minus 3, x minus 4 for some k. Right, okay, so wait. Did they not literally just tell us how to solve the problem? Wait. Do you have to bash this? This is so sad. Wait, the line? No, wait, the line through B and C, right? So A, B, if we... So A, B intersects at D. Okay, my apologies. So this is actually D, right? So D, E, and F, right? I assume AC intersect. Yes, okay, so the line, so if we shift everything, if let g of x intersect, um so what would it be? It would be like negative x minus 2, x minus 3, negative x minus 2, x minus 3 at D prime, then D prime, then because then this is the line AB shifted downwards by x squared. Is it not? Wait. Like, I feel like it is, no? Like, so wait, okay, I'll do one of them to convince myself, right? So okay, like, so this would be like AB AB is like AB is like y equals 5x. What is it? 5x? 5x minus 9. No, 5x minus 6, right? And then the parabola is y equals minus x squared plus 5x minus 6. Yeah, so it is, right? So yeah, so this is correct. So hence negative negative x minus 2, x minus 3 into 6 g of x at d prime, and d prime has same y coordinate as same x coordinate as d, right? Okay, so similarly, negative x minus 3, x minus 4, which is, wait, AC, so AC is x minus 2, x minus 4 into 6 g of x at e prime, where e prime has same x coordinate as e, and negative x minus 3, x minus 4 into 6 g of x at f prime, where f prime has the same x coordinate as f. Right, so okay, so yeah, so we just need to solve this, right? So if negative x, x minus 2, x minus 3 equals k, x minus 2, x minus 3, x minus 4, then like, well, like negative 1 equals k, x minus 4, right? So x equals 4, x of d equals 4 minus 1 over k. Similarly, um, x of e is equal to, should be 3 minus 1 over k, and x of f is equal to 2 minus 1 over k. So 9 minus 3 over k is equal to 9 minus 3 over k is equal to 25. 3 over k is equal to, is this right? 16. K is equal to 16 on 3. Negative 16 on 3. Oh man. Negative 16 on 3 times x minus 2, x minus 3, x minus 4, and then we have, so this would be 5x minus 6. AC would be 6x minus 8, and then BC would be 7x minus 7, 9 minus 21, plus 9 minus 21. Okay, so everything interesting happens like pretty close. So I want to go like minus 1 to like 10 maybe, and minus 10 to like 60. Wait, we did not cook with this. Wait, guys. How did we? Oh wait, so okay, so I need to add x squared plus that. Wait, we still did not cook, bro. What is? What? Wait, yo guys, did we mess up the addition? The sum of the, so you bring the 4. Wait, cause like this should definitely just work. Like, um, the only problem is that like this is not like two. Like this is all correct, right? The only problem is that the intersection is wrong, which is I mean, I guess that is a pretty big problem. Um, yo, like 4 minus 3 on 6. Wait. Yo, guys. I see the problem. I see the problem, guys. There we go. Okay. So if we go with that and that, 2, 3, and should be one more. Yo. Yo, wait, look, I can just like eyeball the intersections, bro. Like, okay, like this one looks like 7. This one's like 8.3, and this one's like 9.3. Okay, 7 plus 8.3 plus 9.3. That's close enough. That's close enough for me. Okay, so therefore, so the y-intercept, hence the y-intercept. So g of x. So f of x actually, f of x is equal to negative 3 on 16, x minus 2, x minus 3, x minus 4, plus x squared. The y-intercept is f of 0 equals negative 3 on 16, negative 2, negative 3, negative 4 is, oh my god, bro. 4.5, okay. None on 2. Yippee, okay. Prove that. Oh, uh-oh. 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 Okay, guys, we might be cooked. We might be cooked. Prove that. Oh, wait, no, this is not that deep, right? Left hand side equals 1 over 1 plus sine x. Okay. I want to multiply top bottom by 1 minus sine x, right? So we got 1 minus sine x over 1 plus sine squared x. Um, 1 plus sine squared x. There's a formula for this. Wait, no, no. It's 1 minus sine squared x. Yo, guys, we're cooking. And then this is just cos squared x, right? Cos squared x. And then what is sine like? Yeah, so wait, so yeah, this is just 1 over cos x times 1 minus sine x times, well, 1 over cos x minus sine x over cos x. Yo, which is just x, sec x minus tan x equals RHS. Okay, as required. So okay, now I feel like so we have to do this integral, right? So obviously they want us to use this identity, presumably. Um, so if we take integral 2 pi on 3, 1 on 1 plus sine x dx. 6 squared x minus. But like, I don't see how this helps, man. Like, this is 6 squared. Wait, integral of 6 squared is just 10, bro. Wait, integral of 6 is just. Bro, do you have to integrate by integration by parts? But like, wait. No, there's just the formula. What the? You just need to apply the formula, bro. Sec x integral of sec x is just tan x, and then sec x tan x is just sec x. That's crazy. Okay, so that's tan 2 pi on 3 minus sec 2 pi on 3 minus tan 0 minus sec 0. Yippee. And then we plug into the magic machine. Minus 1 on cos 2 pi on 3. Okay, that was not very helpful. 2 pi on 3. Okay, that's negative root 3. Negative root 3 minus cos 2 pi on 3. So sec of that is minus 2. Plus 2 minus tan 0 is obviously just 0. Sec 0 is 1, I think. 1. Okay. That's 3 minus root 3. Yippee! I believe this can do a integration. Wait. Calc integral. Oh, man. 1 over 1 plus sine x, comma, 0 to 2 pi on 3? Okay, that's good, that's good, that's good, that's good. Okay, tan of, okay, so we use compound angle formula, right? So tan of, because obviously like pi on 8 plus 3 pi on 8 is equal to pi on 2, right? So therefore tan of pi on 2 by tan addition is equal to tan pi on 8 equals, let's call this like y, let's call this x, plus tan 3 pi on 8 over 1 minus tan pi on 8 tan 3 pi on 8. Okay, what's this? This is x plus y over 1 minus xy. And then what's tan pi on 2? Well, we should know tan pi on 2 is just 1, right? What? Wait. Wait, hold up. No, tan pi on 2 is infinity. Wait, yo. Wait, no, tan pi on 4 is 1. Okay, so by tan addition identity, tan of 3 pi on 8 is just tan of pi on 8 plus tan of pi on 4 over 1 minus tan pi on 8 tan pi on 4, right? And then this is just root 2 minus 1 plus 1 over 1 minus root 2 minus 1 times 1. Wait. Yeah, this is just root 2 over 2 minus root 2. And we rationalize the denominator, we get 2 minus root 2, 2 plus root 2, root 2, 2 plus root 2, Then so you get root 2 plus 1. I think. Oh man, tan 3 pi on 8. Yeah, that is root 2 plus 1. Okay, good. Oh, we're making good time actually. We're making good time. I don't know how we're doing, but hence or otherwise fine. What the fuck? Yo, chat. What is this? What is this? Oh my god. Tan, mate. Wait. Yo, guys. So if we're given, we know tan x on 2 plus y is equal to tan 3 pi on 8, right? So yeah, and tan. So 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 x on 2 plus y is 3 pi on 8 plus n pi for n in z, but also we know tan x on 2 tan y is equal to tan pi on 8 tan pi on 4. Um, Now if if x if 0. Bro, why did they even call this x on 2, bro? Let let a equals x on 2. Okay, so tan a plus y equals tan 3 pi on 8. Tan a tan y is equal to tan pi on 8 times tan pi on 4. Right? Okay, so what I'm thinking is like basically like if if 0 less than or equal to a, y less than or equal to pi on 2, then tan is increasing, so is unique. So a equals pi on 8, y equals pi on 4, or a equals pi on 4, y equals pi on 8 are the only solutions. So basically now we just need to cook up like a solution where like you know what I mean? Like okay, so bro, this is not a good question, like, cause so we know that like a equals 3 pi on 8 plus n pi minus y, right? Okay, so let's just go tan of tan x times tan of 3 pi on 8 minus x. Right, so this is n equals 0. Oh my god, I'm in the wrong place again. Yo, what is this? Wait, is it actually unique? Bro, that's kind of... Wait, how do you prove it though? How do you prove it? Yo. Oh, wait. So yeah, so A is just that, and then... So, then tan of... Yeah, okay, so that makes it... Yeah, so tan of A, tan of Y is equal to tan of 3 pi on 8 minus n pi plus n pi minus Y times tan of Y. Tan of 3 pi on 8 minus Y times tan of Y. Wait, but like still like why does this how do you prove that this like how do you prove that this is maximized, bro? Like at you know what I mean, like find all real solutions. So yeah, like that's what I'm saying. So which is equal to tan of pi on 8 tan of pi on 4. So y is equal to pi on 8 plus n pi or pi on 4 plus n pi. I don't know. Like okay, so I think this is fine. I think this is fine then. So the solutions are x equals oh Jensen's inequality. Jensen's inequality. So um tan wait tan of 3 pi on 8 minus y times tan of y is convex. Concave on the interval um where until like y is 0 to pi, so can only intersect a constant at two places. So y equals, therefore x equals, what is it, pi on 4 plus 2n pi, y equals pi on 4 plus m pi, in integer, or x equals pi on. Oh, that's why. Okay, is the only solutions. Wait, they had x on 2 so that you wouldn't have to write out two different families of solutions, bro. That's crazy. Okay, a local council. Oh, wait, this is like this is like the classic. This is like the classic, bro. They have this. They have this like all the time, no? Like so. So the cost, like lit. Say say they say the cable runs to X from A, where X is X kilometers from B, and then yeah, so the total, so AX equals square root of 30 squared plus 40 minus X squared. BX equals 40 minus X. This is a used calculus, like, so I know I am. So, um, cost in case 1 is 1.5 L. So, L 1.5 30 squared plus 40 minus X squared plus 40 minus X. So, dc over dx is L 1.5 30 squared minus plus 40 minus X squared power negative 1/2. Wait, it must be like, oh wait, bx is just x, right. Bruh. Bro, like, this is the, I swear, this is like the least imaginative scholarship calc question, bro. Like, they come up with this shit like all the time. But, you differentiate that, what do you get? You get like times 2 times 40 minus x times negative 1. And then you have to times by 1/2 plus 1. Wait, let me do this like let 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 w equals kx. Wait, k is bigger than 1. Then the cost is c of x. Sorry, k times l. C of x equals l to kl times ax plus l times bx, which is equal to l times k 30 squared plus 40 minus x squared plus x. Right, so how does this work? dc, you do the same, right? dc dx is equal to l times k, and then we have to do, well, let me actually expand this out, because then it's easier to think about. 30 squared plus 40 squared. Is that 50 squared? Yeah, 2500. 2500 minus 80x plus x squared plus x. So that's 2500 minus 80x plus x squared to the power of a half times a half, because you differentiate that, times negative 80 plus 2x. Okay, and then plus 1 equals 0. So assuming L is not equal to 0, then we have x minus 40 over square root of x squared minus 80x plus 2500 plus 1. So k times that equals 0. So wait, is this real? Like x k x minus 40 equals negative square root of x squared minus 80x plus 2500. And then, well, we just square both sides. K times x squared minus 80x plus 1600 equals x squared minus 80x plus 2500. X squared k minus 1 plus x 80 minus 80k plus 1600k minus 2500 equals 0. Okay, so when k equals 1.5, x equals so 0.5, negative 40, 1600 times 1.5 minus 2500, 82. What the wait, this is not right. Guys, this is a bit sus, man. What why is k negative? This is um okay, let's think about this again. So we bring so ax is definitely this. That's correct, because that's 40 minus x. That distance there, and then that distance is x. So L equals KL. So what ax is that? I mean, the only thing I can think of like is like when you square, like some weird stuff happens, right? Like 1.5 x minus 40 square root of negative square root of x squared minus 80x plus 2500. Holy, this is probably like cooked. Wait. Uh, okay, yeah, so it makes sense. So why is it that when I square both sides, it doesn't make sense anymore? This is very strange, man. This is very strange. Oh, cause it's wait, is it k squared? Wait, but like I feel like even then it shouldn't matter, right? Like you think about it, like okay, well if it's 1.2, yo, yo, if it's 1.2, they should make x negative. That's crazy. Like wait, okay. What if we just plot like the cost, right? Like 1.5 times square root of 900 plus 40 minus x squared plus x. Zoom out. Minimum 13.16. Okay. Now what about 1.2? Huh. Solve minimum. But like obviously this doesn't make sense, right? Because like obviously why would you make x negative? Like right, because you're getting this, right? So okay. Like in theory this should be I guess this should be like um this should be like absolute value of x, right? Um so assuming x bigger than 0, then that. So okay, so yeah, wait, so what's wrong with my quadratic equation, man? Okay. X equals oh wait, I see okay, I see what they're trying to cook up. I see what they're trying I see the vision. 1.5 squared minus 1. 80 minus 80 times 1.5 squared. 1600 times 1.5 squared minus 2500. Okay, so this gives us x equals 13.167 or 66.832. So when k equals 1.2, x equals negative 5.226 or 85.226. Right. So okay. So so we do second derivative, right? So d squared c over dx squared is d squared c over dx squared should be like um that vanishes. So you still get one factor of L and x squared. So quotient rule, you square the bottom, right? So x squared minus 80 x plus 2500. So what's quotient rule? G times, so that's root x squared minus 80x plus 2500 minus x minus 40 times x minus 40 squared over root x squared minus 80x plus 2500. I think that's right. But that would imply that this is always convex, which we know it's not, right? Because it comes back down, like eventually. Uh, oh, wait. What? So the other solution is fake then. So this second derivative is always 0 for all x. Because x squared minus 80x plus 2500 is x minus 40 squared. Wait, no, because you got that x minus 40 squared, right? Hmm. I'm gonna say for all x less than 40. Is that even true? Wait, you got x minus 40. Oh, wait, this is plus, yeah. So it is all x, yeah. Okay. Um, so x, the assumption is that 0 less than x less than 40, which in k equals 1.5 case is true. So x equals 13.167. In in um in k equals 1.2 case, this is not true for um for x equals negative 5.226, but when um so this is only this step is only true assuming x is less than 40, right? That's why we get the fake solution, because this step assumes x less than 40. So x equals negative 5.26 is right? But but gosh, but c of x, c of x is convex up. So x equals 0 is the minimum in the permissible range, since c prime of 0 is bigger than 0. So um, the solution with x less than 0 comes from the fact that bx equals x, whereas it should be bx equals absolute value of x. Like, because if you graph absolute value of x, then then it's fine, right? So okay, so we got 3 more pages. Holy. Wait, it's 1 hour 40. We might not finish in 2 hours, man. Mm. What are they doing? Evaluate the definite integral. Okay, so this is a trick, right? So you can. This is a, right? So the definite integral a, right? A, the definite integral 10 sine x dx is the area a, but then if I take this, then integral 10 of sine, sorry, integral of pi on 2 0 sine of x dx is the area b, right? And obviously one of them is a lot easier to calculate than the other one, right? So um, a plus b is equal to pi on 2, right? So b is equal to integral pi on 2 0 sine of x dx is equal to negative cos x evaluated from pi on 2 to 0, which is just 1, right? So therefore a is equal to pi on 2 minus 1. Nice. Yeah, let's just check that. Calc integral um arcsine of x 0 1. Yep, that's good. Okay. If x equals sine y, oh my god. Find the minimum value of g of x equals what? Oh, brother. And is it part C? Okay, no. Yo, what is this? Yo, yo, guys, we might be cooked. We might be cooked. Um, okay, let's just grind this one, right? Let's just grind this one. Okay, so x equals sine y, show that this. So, well, this is implicit derivative, right? This is implicit derivative. X equals sine y. Sine of y. So d on dx, x equals d on dx, sine of y. So 1 equals cos of y times dy on dx. So dy on dx is equal to 1 over cos of arcsine of x, right? But then you draw your you draw your this, right? So you got x, and then you got sine of x, and then that's 1 minus sine squared of x, right? So wait, oh, wait. No. This is x. This is x. This is x. This is root 1 minus x squared, which is equal to cos of sine inverse sine of x. So this is just 1 minus 1 over x squared as required. Okay, so then g prime of x, right? is equal to, like, see, why didn't it make this 2x, bro? Like, it's just, it's just annoying, right? Maybe it's helpful. Maybe it's helpful. Like, no, I'm gonna substitute. I can't be bothered. Okay, g prime of x, right? G prime of x, arc sine of 2x, right? Arc sine of 2x. So we apply this, right? So what do we get? We get 1 minus 2x squared, and then, well, it's chain rule, right? Bro, are you sure this is arc sine of 2x plus arc sine of pi on 2 pi on 4 minus 2x? Like, what should be the answer? What should be the answer? Point 1963. Hell nah, bro. What? Pi on 4 minus 2x? Yo. Okay, there must be a geometric interpretation to this, but um but we ball, okay. So this is minus 2 over square root of 1 minus 1 minus pi on 4 minus 2x squared equals 0. Alright, so root of 1 minus pi on 4 minus 2x squared minus equals root of 1 minus 2x squared. Oh, okay, wait. Okay, so this is actually, wait. Oh, okay. Okay, that was nice. That was nice. Okay. Um, consider the function. Oh, hell no, bro. What is this? R is a positive real constant. Okay, wait, so actually, this entire thing is constant. That's nice. I mean, if prime. So we just need to find. So if if prime x equals if inverse of x, then if prime of x equals x, right? Because that's what they told us. That's what they told us. So we use what they tell us. We use what they tell us, right? So if prime of x is equal to r times 1 over r to the r to the power of 1 times x to the power of r minus 1. Yikes. So f of this is equal to 1 over r to the r times 1 over r plus 1 times r times 1 over r to the r to the power of 1 over r plus 1 times x to the r minus 1 to the power of r. But this is kind of cooked because, so, right, now if I expand this, then I get 1 over r to the r, 1 over r plus 1. Then what is this? Like, I'm taking, so this is r to the r times 1 over r to the r times r over r plus 1 times x to the r minus 1. Oh, and this is very nice. So this is x times r to r minus 1, which is equal to x. Therefore, r minus 1. So this is for all x, right? So r minus 1 equals 1. R squared minus r minus 1 equals 0. Therefore, r is equal to like, it's a golden ratio, right? R is equal to 1 plus or minus root 5 on 2. Let me just double check that. Yep. 1 plus or minus root 5 on 2. Since r greater than 0, r equals 1 plus root 5 on 2. Nice. Find the lim. Okay. So we need mathematical reasoning, right? Hang on. So okay, so the problem is my stylus doesn't go to the bottom of the page, right? So I need to make a new page. Um, just for that. So h of x is sine of e of x. So h of x equals sine of e to the x oscillates between between -1 and 1 as x approaches infinity. Um, d of dx of e to the x, which is just e to the x, approaches infinity. So these oscillations get faster and faster. They continue as x approaches infinity. So the lim x to infinity of h of x does not exist. Alright, find the exact value of a that generates the maximum value of the definite integral. Nah, I'm cooked, bro. I'm cooked. Oh, wait. Wait, they want the exact value? Yo. Like, yo, okay. Okay, this is what my intuition is, right? My intuition is like, it's gonna be like, it's gonna be like this, right? And then you're gonna have a rectangle, and then you're gonna have like that bit on top, right? Because like, if you go to the right of this, like, if you draw like this, like then this amount that you gain is smaller than this amount that you lose, right? So it's gonna be like in here somewhere. That's my intuition. It's gonna be like in here somewhere, where like h of x equals h of x plus 1, right? Now, I don't know if it's possible to find the integral of sine of e of x. Like, you cannot like integrate by parts, right? Like, sorry, not integrate, but I'm pretty sure like u sub is just hopeless, right? Because you have this e of x. Like, what are you gonna do about it? Like, we find okay, but like I don't even know if it's possible to find like sign of we find we find x such that like x is less than 1. X is less than 1. Sine of e of x is equal to sine of e of x minus 1. But what does that like? What does that even mean? Like, sine of brother, sine of e of x equals sine of e to sine of e to power x equals sine of e to power x minus 1. So x less than 1, that means right. That means we're in like the region. Huh. We might be slightly cooked, guys. We might be slightly cooked. Wait, let me think about this. Let me think about this, right? Because if you think about it, like, um, the maximum value of the definite integral. Yo, guys, like, what are we, what are we trying to cook here, guys? Like, sine of e to power of x. Yeah, like any human with like you can see like the oscillations get more as x goes to infinity, right? But like so if you think about it, like the positive area should be like I don't know. The positive area should be roughly like 1 on e times the negative area, right? Because you would have like does that kind of make sense? Like you'd have like you'd have like x, and then you have like this part would be like x on e, right? So the this part would contribute like 1, and then this part would contribute like 1 on e. Like that kind of makes sense, right? Like so you'd have like 1 minus 1 on e. 1 minus 1 on e. Like you'd have like 63%, like no, but you'd have like 63% of like 1, like you'd have to like integrate. You'd have to like calculate the like okay, like intuitively like I can say oh yeah, bro, it's like definitely here, right? Like but like, how do you prove it this though? Like that's like what's tough, right? Like how do you prove bruh Yo, guys, is Speedy Memes finished yet or nah? How do you? Can you just integrate sine of e to the power of x? Like, is that real? Yo, the graphics calculator is not cooking. Um, hmm. Well, so e to the x is equal to e to the x plus 1. So pi plus that. Is it pi plus that? Bro, well, one of them is like slightly less than 0. One of them is like slightly less than 1, right? E to the x plus e to the x plus 1. No, like if you look at the graph of sine, right? How does graph of sine look like? Obviously, like we're not here, right? Because e to the x is bigger than 0. E to the x bigger than 0, so we must have e to the x plus e to the x plus 1 equals pi, right? Then they're symmetric. And then so you have e to the x, 1 plus e equals pi. So x is natural log of pi on 1 plus e. Okay, and then now I have to write like 2 pages about why this is actually real. Natural log of, what is it? Pi on, yo, what happened? USB device is no longer available. Yo, guys. I think my, I think that my cable came out for my calculator. Okay. Oh wait, that should be better. Okay, like ln pi over 1 plus e. That looks about right. So okay, like okay, so now that's done, right? Like so So we see that um, we see that as x goes to infinity, h of x alternates between between -1 and 1. H of x oscillates 1 rapidly. This means that the integral I as a tends to infinity will have some positive and some negative. So it is better to have a be less than a plus 1 be less than the first zero crossing. Um, but in particular, um, if a less than 0, then like, but okay, but h of x, but h of x has a shape with a maximum, and h is increasing strictly to the left and decreasing to the right for x less than 1. So we should have this maximum in our graph. So in our integral, a should be about 0. Um, and and if we under these assumptions, we should then have to maximize x, to maximize I, x equals e to the power of x equals like h of x equals h of x plus 1. So x equals ln pi on 1 plus e. What was it, 1 plus e? Yeah. I'm gonna call it. Yo, bro, that's crazy. Like we
It
basically
was
finished around the same
neck and
time, bro.
neck. Yeah, neck and neck race at the end. Holy shit.
Yeah, we were. I was fumbling a little bit on the last one.
Yeah, the last question was strange.
Nearly had it. Nearly had it. Nearly had it.
Yeah,
Yeah,
this is interesting paper, man. Interesting paper.
I reckon harder
Interesting
than like
paper.
the past few years by a long way, to be honest.
Yeah.
Yeah.
Yeah. No, because I feel like if you get 3 hours, it should be.
Yeah.
Okay, wait. Do we want to check answers? Because
Yeah.
do you want to go through it, Ian?
Yeah, okay.
Okay, very briefly. Question 1A, 1, 2, 3.
Yep.
Question
One.
1B, I got 2 plus I or minus I.
Wait, 2 plus I on my side?
Yeah. Both of those worked, I checked.
Wait, I just got plus or minus I.
Ooh.
Uh,
Ooh. 2
Wait.
plus I does work. 2 plus I does work, I can confirm.
did I miss a solution? 2 minus I divided by.
Wait, I might
Hey,
have.
that doesn't work. Wait.
Yeah, I doesn't work. I doesn't work.
Okay.
No, wait, it is 2 plus. Wait. Yeah. It is 2 plus or minus 2. Wait, it's 2 plus I or just minus I. Yeah.
Yeah.
Wait,
Still like
I got like 1 plus or minus 1 plus I, and then for some reason I thought that was a plus or minus I. Okay.
All good, all good.
So
Okay. And
okay,
then
that's
2027 for 1C.
yep.
Okay. 7 over 4
1D.
plus square root 3. Could be wrong.
Yeah, I got that as well. So
Okay, that's good, that's
okay.
good.
That works. That
And
works.
then we got 14 for
yep.
question 2A.
14. Yep. Yeah.
Okay. Just 2025 for 2B.
Yep.
And then I got 4.5 for 2C.
Yep. Okay. Yeah.
Oh my god, we're
Yeah,
actually insane.
that's real, that's real. Then Alex cooked up 3 minus square root 3 for the next one.
Yep. Yeah, I got
And
that
then
too. Yeah.
square root
Huge,
2
huge.
plus 1.
Yep.
The
Okay.
next one I'm not sure about, to be honest.
Is it pi on 4 and pi on 4? Like x equals
So
y equals
I
pi on
got
4?
Yeah, I
pi over
think.
2 and pi on 8.
Wait,
With
what?
What? No, it can't be pi on a. It can't be pi on a.
uh
It's just pi on 4 and pi on 4, is it not?
Yeah, I'm pretty sure it is just
Yep.
pound four, pound four.
the
Yeah.
next one
Yeah.
did I do this
Yeah.
one?
And then
This one?
plus n pi's and everything, but
Yep.
because like the proof is in the pudding. But the previous question is telling you tan pi on 8 is root 2 minus 1. So that topic solution,
Yeah.
if you just make x pi on 4 and then y pi on 4.
Wait.
it's one of them, right?
Let me just very, very quickly fact check myself here.
Wait, what
Wait,
did you guys? Wait.
I'm pretty sure I told you this, Nico, and then we moved on.
This might be a bit of a fumble. Might be a
Oh
fumble.
no, we've lost the race. Quality over quantity.
Wait, what did you guys do? Wait, you guys expanded.
What? No. Because this is looking real. It's looking pretty real. Because if I do,
But pi on 4 works though. Does it not?
does it?
Yeah, it is. Wait. Well, what
Wait,
did you guys
Oh
cook
no.
up?
Oh wait. I think okay. Here's what I think happens. I think that we possibly have the same answer, but since I've written it really weirdly with the n constants, my base values are looking different to your base values, but it could all be equivalent.
Wait,
the previous
wait.
question-
Go back down. Wait, what? Where's your
The
Wait,
previous
you're looking on my
question tells
screen.
you, like
Yeah, I opened your stream, bro. Wait, pi on 2.
Because
my God,
n1 and n2 can
Pi
be
does
anything,
math
right?
in the chat. That is a generational pull.
Wait, no, because
Yo,
if
what's up,
you
Mark?
sub like n1 equals n2 equals 0, right?
Yeah, then you get pi on
Do you-
8. and then pi on 2, which is a solution, I'm pretty sure.
Wait,
Is
did
it?
I miss a solution?
Pi on 8, pi on 2. Really? Really? Hang on, I'll just check that.
Yeah, because
Wait,
Tan of
but
pi on
tan of
2.
pi on 8, it should be like negative. 5 pi on 8, tan of 5 pi on 8 should be
Okay,
negative, right?
we're checking this possible solution x equals pi over 2 and y equals pi over 8. The first equation, does that work? Tan pi on 4
Yes, that works.
times
Yep.
tan, yeah. And then the second
Yeah.
one, that also should work.
Yes, it does,
Shouldn't it?
yeah.
Wait,
Pi
So
on 4. Yes, so x equals pi on 2, y equals pi on 8 works. Yeah, shit, yeah, yeah, and then otherwise x equals pi on 4, y equals pi on 4 also works as well. Shit, alright.
yeah, but I caught that one in my second. See my second one, my minus root. I got that
Yeah,
one. Yeah,
yeah.
pi on 4. Yeah.
Okay, huge.
So
yeah,
this
yeah, wait,
might be slightly non-trivial. I don't know.
wait,
Because-
wait, I realized, wait, I got 8, I had like a equals 2x, right? And I was like, a equals, wait, a equals pi on 4, yeah, wait, yeah, x equals pi on 2, y equals pi on 8 works as well, yeah.
Yeah, okay, that's kind of rough.
Okay. Yeah, I got a strange. Yeah. Okay. Anyway, x equals for the option part C. X equals like 26.83 and like.
And then straight line.
Or
Yeah,
have you used?
I did it the other way, but yeah, I think it's equivalent.
Yeah.
I got like, wait, 13.16 plus 26.83 is like 40, right? Yeah.
That looks pretty real. And then the other one's like outside the range.
Yeah.
So
So you just make it straight, yeah.
Okay,
Yeah.
huge.
Right. And then next one's pi over 2 minus 1.
Yep.
And then we got just 2 times inverse sine of pi over 8.
Oh. Wait. Wait, shit. I didn't plug it in, but yeah, I mean, like
But,
I got
x
x equals pi on 16.
pi over 16. Yeah.
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 It's a
Yes.
strange question though, right? Because it implies you're gonna put like an angle back into sine inverse, which doesn't make any sense, right? Because you don't sub angles into inverse trigonometric functions, right? You sub
Yeah.
values in to get angles back out. So it's just a goofy question. All ends up.
Okay, the next one, we got the golden ratio to the power of
Yeah.
the other golden ratio times x to the power of golden ratio. Question mark?
Wait, what? Wait.
Wait, check
Where's
out.
the golden ratio, right?
So it's x to the power of the golden ratio, right? But then, do you need a constant out the front of that?
Oh, wait. No, they just asked for R, bro. They didn't ask
It's like
like
R.
yeah. I think it's the
Oh.
same, yeah.
Yeah. It's just
Oh
golden
wait,
ratio.
what? So I didn't need to do the last bit, but you do need to check that the. Okay, so this is pointless. This little last one.
Yes, I don't know about what we're doing there.
Okay. And then.
Wait, you know what's crazy? Like the constant in front, like it just cancels regardless of what R is. So the only thing that matters is like the power of x.
Yeah. It's kind of beautiful.
It is kind of beautiful, bro. Bro, no, it's not beautiful. They just engineered it that way, bro.
Oh, huh.
Yeah.
Yeah.
So-
Okay. And then no limit.
Well, there's zero
Wait,
and no limit, right?
The left limit is 0. The right limit is d and e.
Wait, they asked for the bro. I forgot to give the lift limit, bro. Okay. Yeah, you got me. The lift limit is 0, yeah. And then the right limit is D and E, yeah.
And then
Crazy choke.
find the value of a that generates. That one, ln of pi over e plus 1.
Yeah.
Yeah.
Yeah, that's what I got as
think-
well, yeah.
Yeah. Okay, so that's not actually too bad. That whole paper, I feel like.
No, I don't think I think the problems themselves were harder, but I think there were less of them. compared to previous years.
Well, okay.
That's true.
If you do the average difficulty across all problems, it might be harder, but there's no single problem that stands out as remotely that difficult, right? You get what I'm saying or not?
I feel like question
Eh,
2C, the cubic question, that was quite rough. I don't think
2C.
that was that easy. Yeah, the
I
cubic
thought
question.
2C was like. I thought 2C was like easier than I thought
Really?
1D was pretty hard. I think I lost a lot of time on 1D, and then someone in my chat like told me I was like very
Oh,
behind, so I had
oh,
to make it up on question 2.
1D is like, it's a question that is just computationally heavy. Like, there's nothing that's not that hard to understand in the question. Like, you can plot Z bar 1 on Z and IZ reasonably easily, right? And then it's just geometry. It just takes time.
Then I would say like 2C, like I think that they basically tell you how to do it, right?
Yeah, it's true, yeah.
2C.
Like if there was not the hint, I would say like yeah, 2C is like pretty tough.
Yeah.
Yeah.
Question 3 is the easiest, I'd say. I think all of that's pretty good. Like,
Yeah.
part A is easy, part C is pretty easy as long as you realize it's outside the range. And then
Like
B in just works. Like,
yeah.
I suspect that they'd like okay,
I
but
don't
like
know. I thought 4C was kind of tough. Like I don't know. Like you had to like kind of get the
I
intuition,
feel
I
like
guess.
I feel like I was just trolling for that one, to be honest. Like, it's not too bad because you just look at it. Clearly, winners
Yeah, how do you prove
optimized.
it, bro? How do
At
you
least
prove it, though? Like,
it says, look, it says you may use the graph above to justify your answer.
so you just say whatever, right?
No, okay. That implies that the level of rigor that you need to actually do it is like you can just ignore it and say, look at the graph, bro, trust. Yeah.
yeah, well, okay, yeah. I guess that's true. That's true.
It's
I
not
mean,
as bad
I
as the
wrote like
last
3 paragraphs, bro. Like that's crazy.
Oh, okay, yeah, yeah. Maybe a bit more yap would have been good there. And
No
yeah, I
K
forgot to do
Dash says, do an epsilon
I forgot
delta
to do
for doing
the convexity yap. Okay, can you leave the epsilon delta? How you do this? Like, I mean, it's just not
Wait,
that bad though, because you can just show that there's infinitely many solutions to get
yeah.
1 and -1 of things, so it fails. Um, yeah, it's okay. I feel like the thing about this paper is no question conceptually is that taxing yet, maybe, but there's so much random computation that most people will have definitely done a silly on at least one question, right?
Someone on Reddit says you can integrate sine of e to the x as minus cos e to the x to the power of e to the x. So, I don't think so.
I'm
What is that
pretty
real?
sure.
It's on Reddit. Just go
I
r/e
highly
to the
doubt
a.
that you can integrate that. Can you
No,
integrate
you
that?
can't. You can't. No.
It's a non-elementary integral, bro.
Exactly, it's not. They've
Yeah,
just
bro, there's yeah doubt on that one. Uh, um, yeah, I mean, I feel like there's not that much to be said because there's not really. I mean, we say that and they might have fumbled something, but
Hmm.
I mean, we
Oh,
we
by the
kind
way,
of all three of us like fumbled, right? Like if we agree, like it should be right.
yeah, like realistically, if I sat this, I'd probably like fumble like at least one question. Like,
I think you fumbled a question last year and still got 32.
yeah, but is yeah, true.
I
No,
would
but
like
the
to
thing
take
is,
this moment to shout out a video I recorded 6 hours ago on my YouTube channel. It's a glorious one. Go watch.
all right,
Shameless,
we'll do.
shameless self promotion.
Hmm.
Okay.
Yeah, well, I think that's kind of a wrap. I mean, it's cutoff estimations.
I reckon
Bro,
18.
I don't know, man. I don't.
I reckon actually 17 for us. I'm gonna be generous. And
No, I
then,
mean the outstanding cutoff.
But bro, but like
I think-
they scale like the 6, 7, 8
Yeah,
marks. Like
they
it's
scale
a
it
bit pointless
really,
to yap.
really hard.
yeah, yeah, you're right.
Yeah, but
It'll be 28.
28. Yep, I reckon 28
Sounds about right.
plus or minus.
Well, 1. Yeah, plus minus 1.
Yep, I reckon that's a job done. I don't know about well done, but it was done.
It was definitely done.
So yeah, I think
Yeah.
that's hope everyone got where they wanted to get with the paper, and yeah, it's I'm running out of things to say here. I can't lie. Do you have anything to add?
Yeah, I mean, like,
Yeah.
there really isn't much to add on, is there? Is there any more? Wait, what scholarship exams are left? Is there anything of interest?
Bro, is Chem left?
Nah, I speedruns Kim
Kim already
Monday,
came out.
Tuesday, yeah.
That's
It's a legendary
crazy,
Yeah,
bro.
Alex is fighting the fight.
Bro, scholarship
that-
Chinese, bro. Oh wait, that was today. That was today. Scholarship.
scholarship.
Wait, BMO one
Yo,
speed
who's
run
on that
wins.
scholarship history grind set, bro?
Scholarship
Oh,
history? Yeah, maybe.
yeah, the Ducks from my high school this year is doing school history. She's like grinding it or something.
Skull RE. Yeah, shout Aiden Park. What is even the theme for Skull RE?
We will not be doing scholarship religious studies.
Wait, remember when Grady Koenig's got that a few years ago, Ethan?
Yo, bro.
He was top scholar.
That's
Oh,
crazy,
wait,
man.
Wait,
That's
do you
crazy.
remember?
I remember this, bro.
What year was it? 20,
Bro, it would be like 2021, right? Like 2022, maybe.
2022. No, 2022. He was top in RE. One absolute mad lad. That's
What a go, man.
yeah.
how do you get top in RE?
Yeah. Okay. So
Should we
think
just
think we're ending the stream.
Yeah,
Should
bro.
I know
we-
we'll fill in the
GG's, guys.
GG's. Yeah.
Thanks for coming,
All right.
guys.
Rightio.
Thanks for watching the stream, guys.
Thanks for pulling up. Yeah. See you next year, maybe.
Yeah, see ya, man.